Continuing our investigation on law of cosines. So I didn't write out, out all the rules again. This can all be turned around differently, but I'm going to start with a squared is equal to b squared plus c squared. Look, BC minus 2BC cosine alpha. This A and this alpha are opposite each other. So if this is angle alpha, well, this is side A. If this is side beta, this is side, I'm sorry, if this is angle beta, this is side beta, side B beta. And if this is angle gamma, then this is side C. So they gave us all the angular values. So what we're going to be working with is a side example. And all I'm going to do is this. And I'm actually going to do all this algebra for you on this, for this one case. I'm going to take this algebra right, I'm going to take this right here, and this is what we're missing, right? I need a side. So what I'm going to do here, if you don't mind, is I'm going to do algebra, and I'm going to try to get this thing by itself. I'm going to try to get my cosine alpha by itself. So the first thing I think I'm going to do is I'm going to switch these. I'm going to move this piece over to this side, move this A to that side, and I think that gives us this. I'm humming a lot today. I'm not sure what that means. Right then, 2BC cosine alpha is equal to b squared plus c squared minus a squared, just algebra. I move this here and this there. Remembering now that what I really want is this. I want, right, we just talked about this, that what we really want is this. So this is that cosine alpha I was looking for. I want this cosine alpha by itself. So I'm going to divide both sides by 2BC, right? So that would give us cosine alpha is equal to b squared plus c squared minus a squared all over 2BC, right? So if I divide this side by 2BC, this goes away, and it ends up over here, doesn't it? So hopefully that's good algebra for you. This is really important to me. What I've done here is I've put all the known values on one side and the variable on the other. So here, this is just FITBA. This is just fill in the blanks. I finally got this thing simplified. So I can say this with some certainty, that cosine alpha, which is what I don't know, because what I want is the angular value here, is this. It's 70 squared, because side B is 70. I'm just picking these pieces up. Plus C, which is gamma, so go across, that's 40 squared, isn't it? 40 squared, right? Minus A. So here's angle alpha, here's side A, is 90 squared. In a minute I'm going to use a calculator, just because I don't want to try to impress you guys too much with my inability to do long multiplication. So this is definitely, tell your teacher I said this is calculator stuff. There's no need to waste our time with this. And this comes out to be negative 2/7. So that's simplified out pretty good. I didn't actually see that coming. Now remember, what we want is we want alpha, right? We're missing alpha. We're not missing cosine alpha, we're missing alpha. So what we know for certain is that our angle alpha is the inverse, so cosine to the negative first, right? Inverse of cosine of negative 2/7. And when we put that again into our calculator, you told your professor, we're going to get a value of about 107. And you should ask your professor or your teacher for some rounding advice. So about 107 degrees. So look, this works out pretty good for us. I think this is about 107 degrees. So I'm going to do another problem, I think. I'm going to keep working here. And I'm going to try to get, let's try to get beta. So we're going to try to get this angular value beta now. So I'm going to look for this angular value beta right here. Look for this. And what I'm going to say is this. I'm not going to do all the algebra this time. It's going to same algebra as it was before, just different. I'm going to say the cosine beta, after I rearranged all of this stuff, turned out to be a squared plus b squared, right? No, it didn't. A squared plus c squared minus b squared, right? If you put it into the equation, all over 2ac. And when I put all that stuff in, that turns out to be 90 squared plus 40 squared minus 70 squared all over 2 times 90 times 40. Are you thinking calculator? Because I know damn well I am. And then remember this, that we're looking for this beta value, this angular value. So what we want is the inverse of cosine of beta, right? which is going to give us, oh, when we did this math, we got, what did this work out to? This works out to, oh, about 2/3. So this value is about 2/3. So, of 2/3, which is equal to about, let me see if I got, about 48 degrees. So about 48 degrees there. So I'm going to go back in here. Now we can use triangle sum theorem, right? If this is 48 degrees, well, then we know that, right? I'm going to look for this value, but this value is much easier because we're going to get, it's 180 degrees, triangle sum theorem, right? Minus 107 plus 48 degrees. And that's equal to 25 degrees. So we get 25 degrees here. Problem solved. 25 degrees. Man, that's a lot. Let me say this to you guys clearly. I don't think this is extremely difficult. It's just a lot of stuff. And to start with, you have to know how to label a triangle. 2, you have to have memorized these formulas. And then just remember to fill in the blanks, right? And ask yourself, what value are you looking for? And what is that value? Is that value a distance? Is it a length? Or is it an angular value? And make good decisions based on that. So I hope this is really helpful. If you haven't already subscribed, please do. And your comments are always welcome.